Earth weighs about 6 sextillion tons. So why doesn't it fall down? It's a question you've probably asked since childhood. But today, I'll tell you the truth. The Earth is actually falling all the time, and it's been falling for 4.6 billion years. The only difference is, it's not falling down, it's falling toward the sun. What's even crazier is that it's been chasing the sun for 4.6 billion years, and it still hasn't caught it once. So what's really going on? This video might completely change the way you think about floating in space. First, here's a harsh truth. In the universe, there is no such thing as down. All your life, you've been told that things fall downward. Apples drop when they ripen. If you jump, you come back down. But what makes that happen? It's Earth's gravity pulling you. That's what tells you which way is down. But once you leave Earth and go into space, every direction is just darkness. There's no floor, no ceiling, no walls. You could travel 100 million light years in any direction and never hit anything. So falling down is really just a concept that exists on Earth. In space, there is no down. And if there's no down, nothing can fall that way. So here's the question. If there's no down, why doesn't Earth It won't stay still, it'll roll toward the heavy ball. If the marble has enough sideways speed, it won't fall straight in. Instead, it'll circle around it. That's the relationship between Earth and the Sun. The Sun is about 330,000 times more massive than Earth. It presses a huge dip into the space-time around it. Earth is like that marble, sliding along the curve. We call that motion orbit. So Earth isn't being pulled around the Sun. It's moving straight through curved space-time. But in a curved space, a straight path can become a circle. It sounds strange, but the theory was confirmed in 1919. That year, British astronomer Arthur Eddington used a solar eclipse to observe light from distant stars. He found that the light bent as it passed near the Sun. Light normally travels in straight lines. If space-time were flat, light wouldn't bend. But it did. What does that mean? It means space-time near the Sun is curved. Einstein's theory was proven right, and the world was stunned. From then on, we truly understood gravity's nature. It's not a force, but the effect of curved space-time. Now we know Earth moves within the Sun's space-time curve. But here's another question. If Earth is always sliding toward the Sun, why doesn't it fall into it? The answer is its sideways speed. Remember the marble on the rubber sheet? Without sideways speed, it would roll straight into the heavy ball. But with enough sideways speed, lapse, and it started spinning. Why did it spin? Because matter in the universe already carries angular momentum. It's a law of physics, called conservation of angular momentum. Simply put, once something starts spinning, it's hard to stop. Like a figure skater pulling in their arms, spinning faster. The nebula behaved the same way. As it shrank, it spun faster and faster. Eventually, the sun formed at the center, and the surrounding debris formed the planets, including our Earth. Earth inherited that spin, so it was born moving. That's where its speed came from. No one pushed it. It's been moving since the moment it formed. But speed alone isn't enough. Earth has stayed stable for 4.6 billion years because of a delicate balance with the sun. If Earth moved too fast, it would break free and drift into deep space. It would become a rogue planet and eventually die in the cold and darkness. If it were too slow, it would be swallowed by the sun's space-time well and fall into the sun in flames. Only the right speed keeps Earth from escaping or falling in, letting it orbit the sun in peace. So how did it get that perfect speed? The answer is a bit harsh. The universe filtered it out. When the solar system formed, there were countless fragments and asteroids. Those moving too fast escaped. Those too slow fell into the sun. Only the ones with the right speed survived. Earth is one of those survivors. Newton explained this with a thought experiment over 300 years ago. He imagined a cannon on a very tall mountain firing horizontally. If the cannonball is slow, it follows an arc and falls back to the ground. If it's faster, the arc becomes longer. If it reaches 7.9 kilometers per second, its arc matches Earth's curvature. It keeps falling toward Earth, but never hits the ground. Because Earth is round. As it falls, the ground curves away beneath it, so it never catches up and ends up orbiting Earth. That's the origin of orbital speed. And the same idea explains Earth orbiting the sun. So in a sense, Earth is always falling. Its direction just keeps changing, which forms an elliptical orbit, and it's very stable. Scientists say Earth's orbital eccentricity is only 0.017. That's almost a perfect circle. Earth is like a skilled skater, gliding around the sun for 4.6 billion years, without ever falling. But this stability isn't forever. In fact, Earth is drifting away from the sun by about 1.5 centimeters a year. The reasons are complex, mostly tied to solar mass loss and tidal effects. But don't worry, at that rate, in 100 million years, Earth will only be about 1,500 kilometers farther out. That barely affects its temperature. What really matters is the sun's lifespan. In about 5 billion years, the sun will run out of hydrogen and become a red giant. It will expand to more than 200 times its current size, swallowing Mercury and Venus. Earth might not be swallowed, but it will be scorched into a barren rock. The oceans will evaporate. The atmosphere will vanish, leaving behind a lifeless stone world. Of course, that's 5 billion years away. After all that, there's one more question. Earth is racing through space at 30 kilometers per second, while spinning once every day. At the equator, the spin speed reaches 465 meters per second. So why don't we feel it? The answer is simple. We're moving with Earth, and that motion is constant. Think about it is the same. Its rotation and orbit are nearly constant. There's almost no change in acceleration. So we don't feel it. And everything on Earth, air, oceans, mountains, moves along with us. We have no stationary reference point, so the motion is impossible to sense. That's inertia. If you've taken high school physics, you know Newton's first law, the law of inertia. Now let's sum it up. Earth doesn't fall through space for 3 main reasons. First, there is no up or down in space, so the idea of falling down doesn't really apply. Second, that the sun's mass curves the space-time around it. Earth moves within that curve, creating an orbit. Third, Earth has enough sideways speed that as it's pulled toward the sun, it keeps moving sideways, and that creates a stable orbit. This system has run for 4.6 billion years, and it will keep running until the sun burns out its last bit of fuel.